Okay, let's get started. So hi everyone, I'm Michael Staib. I'm a Microsoft MVP and I'm one of the authors of the Hot Chocolate GraphQL library for .NET. Today I want to talk to you about GraphQL schema stitching with .NET Core, or I would rather say federated data graphs with .NET. I know that a lot of people in talks every time I go to conferences that don't know what GraphQL is. They just hear the term graph. So let's introduce do a 3-minute introduction to GraphQL and then head into the topic. So why is GraphQL so popular lately? Why does everybody want to build his own data graph, create its own GraphQL server? So the reason for this is because GraphQL changed the paradigm how we consume data. With traditional REST APIs or even gRPC APIs, SOAP APIs, we always have to take what the server tells us that there is. So if a server offers a request, we have to swallow all the data that the request offers to us and just live with what the server offers. With GraphQL, this is fundamentally different. Like if we look at this simple GraphQL query here, which fetches the currently logged in user, and from this currently logged in user, just the name. When we send such a request to our server, we get a response back that closely aligns our request. And that's one of the design goals with GraphQL. It puts the consumer of the API in the driver's seat and lets the consumer drive how the interface between the server and the client really looks like. So if we look at this response, it almost is as if the server just filled up our request graph with some data. But GraphQL doesn't stop there. So I cannot just build simple requests. And as my demands change, I can change my requests, add more to my request that I want to consume. Like for instance, I want to drill into the profile picture and get details over the profile picture of the user that is logged in. And I can send that again to my GraphQL server. And as we expect, the GraphQL server will just fill that up with some data. And as we now can already reason about, it's not all about simple sparse fields or simple requests where I just can say, give me this and that field. It is really about data graphs where I can drill into the relations of my nodes. Like for instance, I could drill into the friends of the currently logged in user and ask for the name and last thing of the signed in user and of its friends. And as I expect, I get the data back also for this in the shape I expected. But if we look closer here, we can see that we already introduced some repetition into our GraphQL query. Name and last seen is declared 2 times. And there is a construct in GraphQL called a fragment, which is our primitive for composition. And with that, we can build fragment hierarchies as we create component hierarchies in our UI or class hierarchies in our backends. So with GraphQL, I have a single endpoint. Since I'm designing the requests or I design what data I want to consume, so I can issue that to one endpoint. That makes it that simple to use. And with GraphQL, I can consume all the data that I need at a given moment in time or that I need in a specific component with one request. And that completely gets rid of the over or under fetching problem. And GraphQL is built on a strong type system. And that gives me confidence when I consume data, since the GraphQL execution engine will enforce that the data abides to the declaration that we did in our type system. And this is different to things like Swagger, where the schema essentially can get out of bounds with the implementation. And that makes GraphQL super predictable to use. Okay, so with GraphQL, I aim for this big data graph, for this, I would say, monolith, in which I can really reason about data, drill into data, ask for everything I want. So ideally, when we build GraphQL, we just put a thin layer of GraphQL over our business layer. And GraphQL is a really great way to expose or give access to our business layer. It essentially lets us create this ubiquitous data graph where we can explore our business layer in a much better way than with traditional technologies like REST, where I always have to simplify my data, put it in serializable objects. So when we start with GraphQL APIs, we often start by creating our model that we want to consume, an interconnected graph. If we, for instance, would build a web shop, we could start like this, where we create a user. That user is connected with the reviews that this user writes. I can drill into that. And the review, for instance, is connected with the user, so I can drill from both sides. And also we have the product that is in the center, and where we can also drive into the reviews that somebody wrote about this product. This is great. It really lets us drive and define our graph in a really rich way with rich types. And from a query standpoint, from a consumer standpoint, this is really great, because the front-end developer or the consumer of the API in general can just drill into the data. For instance, from the currently logged in user, you can drill into the reviews that this user has written, and from there into the product about which this user has written reviews. And also, as I said, we can explore this from the other side by, for instance, asking for the top products of the web shop, and then exploring if these top products are available, what the shipping estimates are, and then drilling into the reviews and the author who wrote the reviews. This is great from a consumer standpoint. But as our graph grows and introduces more and more types, it becomes cumbersome to have just a monolith. Often GraphQL is used then over a set of domain services. I'm not speaking of microservices here, since usually you aim to have domain services down there. And these domain services now can be developed by different teams that work in their silo with their domain expertise and push this server forward. But the problem that now arises is that if I divide that up into those silo services, domain services, I always have to advance this domain service and the GraphQL layer as well. And that means every time I change, for instance, the account service, I have to change the GraphQL service. And this introduces new problems with working together as teams, because now I always have a log when somebody is changing something in the graph, and I have to wait for the changes to commence. So ideally, we would like to have these silos where we, for instance, in the account service, just have the user, just have to care about the data of the user. In this instance, we have just the name of the user. And in the product service, we might just want to have a catalog of products, and which essentially consists of the name and the price. And then we might have a third service, the inventory service, that keeps track of what we have in stock and what the shipping estimates are. And ideally, these services could also provide some configuration to our overall graph to tell the overall graph how these types really interconnect. Ideally, our account service could just tell the overall graph that this user is essentially the author in the reviews. And in such a scenario, we would like just to have one technology, just GraphQL, where the overall graph can delegate the query parts that concern one domain service to that domain service. And on the other side, I want to drive this graph from the bottom, from the domain services, and build out the types in my domain services, and then create a bigger and bigger data graph for my company. So the solution to that is graph distribution. And we have a couple of approaches here. So there is schema stitching, which is a centralized approach where the gateway essentially has all the stitching logic and knows how to combine these graphs. I would end up with the same problem I introduced with having these domain services down there, where I always have to advance my my domain service and the overall graph at once and create those locking scenarios. But then there is schema federation, which essentially defines that the domain services by themselves can build up that top level graph. Both terms were coined actually by Apollo, but there are a lot of flavors around in the GraphQL hemisphere. What I'm showing you today is how you can do that with .NET Core and Hot Chocolate. And I would say, let's just dive in and look how we could build up such a distributed graph. Okay, so I prepared a little demo. Let me just pull that up. And let me just compile that so Visual Studio Code knows my types. And I'll walk you through a bit. So essentially, I have built 4 GraphQL services here: accounts, inventory, products, and reviews. And each of these provides different aspects to my overall graphs that we want to create. So if we look at the accounts graph, it's a simple GraphQL server. Let me put that aside. It's a simple GraphQL server that has a simple query type that provides us with a field to fetch all users or a field to fetch a single user. The user is also simple, provides just name, birth date, and username. So just a couple of data about the user. And then I have like the review service that provides me with essentially the review, and the review service knows some IDs about the author who wrote that, and these really interconnect with my accounts data. But each of these services owns their data silo. So they own the data that they provide. So in order to interconnect these domain graphs, I need to have something called a gateway, a GraphQL gateway. And for that, we just need to create a simple .NET project. So .NET new web, and we call it a gateway. And just let's add it to the solution so that I can compile, just reload. So Visual Studio gets it that there is a new project. So the gateway is a very simple ASP.NET Core application. It doesn't have anything in there. So the first thing to use federated schema stitching is essentially to add some GraphQL to it. So let's put the Hot Chocolate ASP.NET Core package in here. And Then we also need a package that lets us do all this schema stitching magic. And that is the Hot Chocolate stitching package. And in this, we are using a federated approach. That means we want to have it more robust, and we need some kind of an instance that lets us push messages between those services and also store the configuration. And for that, we are using Redis. There are other things that you could use, and you could even use a pull approach. But with Redis, you have really a hot reload approach with your schema. So before we head into really all this setup here, we also are using a tie here. That means to not always start all the services, I just put that in a tie configuration. And let me just also put in here the gateway configuration so that everything compiles. So the nice thing with tie is that I now just can do .NET Tools tool restore, and then .NET tie run watch. And now we can work on our gateway, our microservices here, and tie will automatically restart the part that we are changing. And also tie will distribute as a Redis cache and stuff like that and keep everything running. It's a great way to also debug those federated data graphs on your local machine. Okay, so let's get into it. So the first thing is we want to set up a gateway, a GraphQL gateway. So we are going into our gateway solution, going into startup CS. And we need to set up a simple GraphQL server here. So we would normally start with services.add GraphQL server. And then maybe we want to have a simple query type in there. And since this is a gateway, we just provide an empty query type, since we will fill it up from the domain services. So we just give it a name, call it query, and we leave it like that. So this is a GraphQL server. It's not a valid GraphQL server, so it would fail when we call it, but it's a GraphQL server. And then we essentially map GraphQL as an endpoint. And with that, we could execute GraphQL queries. But in order to push configurations to this GraphQL server, we now need to connect it to Redis. So let's put in the Redis connection to our dependency injection, and then import the remote schemas, so the schemas that we are pushing to it from our Redis. And we're giving it the configuration name demo. So that is essentially our name, our configuration name. And with that, essentially the gateway is almost configured. The one thing that we are missing is the connections to our downstream services. And for this, we are just using the HTTP connection, HTTP client factory, sorry. So I'm adding here 4 fixed HTTP clients that can that represent all the downstream services. The cool thing here is you could also implement that in a more dynamic way, where you also get from Redis the configurations. And the cool thing with HTTP client factory in general, you can make it very robust by using Poly or some other tooling. Okay, so the gateway is now ready. Let's push some configurations. So let's start with our account service. In our account service, we have fundamentally a simple data graph. We already explored that. Let me have a look at how this data graph for accounts looks like at the moment. We are opening this GraphQL server. Let's just have a look at the schema. At the moment, we just have 2 fields here on the query type. So we could, as we already saw in the code, fetch all users or fetch a specific user. Awesome, that works. This is a simple server that we have down there. But what we saw in the slides, I had this nice schema with me where I could drill in. That is actually what we want to have on our gateway, on our overall company data graph. So let's get into our configuration here and first put in Redis so that we can push our configurations from our domain service up to the gateway. The next thing we need to do is to publish our schema configuration. So essentially what we are publishing here under the name accounts to the overall stitching configuration demo, our schema. But we also can modify our schema, rewrite our schema. So for instance, we are ignoring all the rule types. So we are ignoring users and we are ignoring the other user field. What we really want to do is rewrite our data graph. And this we can do with GraphQL SDL. So we can put in a stitching.graphql here. And then we can extend the query type that we have in our gateway. In this instance, I'm introducing a new field that is called me and is from the type user that I have here in my downstream service. And I can call that by calling the user field on my service and providing an ID. In this instance, I'm taking a static ID. Usually with authentication, I would take that from the context. Okay, so let's just add the type extension here, the file, and with that already our data graph should work. Let's go to our gateway, which is on port 5050. Okay, it's loading. And we already can see that we now have a me field here. There's nothing else to it. So we could essentially now already query our user, our currently logged in user. Okay, but that is just a simple thing to do. We really want to interconnect the data graphs. So the next thing really would be to go to the review service, go to the startup CS, and also connect that to our data graph. So again, we add Redis. And then publish also our configuration of this service to our gateway. And again, we are ignoring all the rule types because these are more meant for the domain service. We want to rewrite the configuration here to integrate with our types that we have on the gateway. So stitching.graphql again. You can name it however you want. So it isn't fixed to that name. So in this instance, we are extending the user and we are introducing a reviews field here. And here you can actually see we are taking out of the context from the original entity the ID and try to and resolve with that ID the reviews that belong to that user. Okay, this is already working again. Like I said, with Redis and Thai, this is really hot reload. So we can just refresh, go in here, and we can already see that our reviews type is stitched in. And we can now really drill into that. The good thing is that the GraphQL query engine will figure out query plans to query that effectively. It also knows about overlapping data that you have in both services. And we also try to reduce the servers that we involve when we are resolving the data. Okay, but let's go on with that because review also actually should expose the user. That means we could go back to our account service here and essentially extend the review type with the user. Again, we are taking the author ID from the review type and resolving with that the author. And again, this is already hot reloaded. The schema already has this capability. There's author, and we can drill further into the data. Okay, but now let's really interconnect the product service, make that shine, and also connect that with the inventory. And the inventory is quite another thing. So we again go to our service configuration from the product service now. Again, we add Redis. This becomes now muscle memory. We are just adding these things. We are publishing the products details. And also with products, we are introducing a stitching.GraphQL. And products is also reachable from the query type. So let's also introduce a new top-level field to our query type. This is top products. We can get top products and provide an integer how many top products we want. In this instance, I can just delegate without any information because the same field exists on my domain graph. And then we can extend the review with the product. And in this case, we need some context information that we get here by using this context variable, which we then delegate to our local domain service. Okay, this is already reloaded. And we now can really drill into our top products here. Take the first two maybe and drill into the data that we have. So while there is no interconnection yet, we already can drill into the product from the review. You can see we just need to define how the edges connect. And then the data is already exposed. Okay, last but not least, let's put in the inventory, and then I show you something different. So again, we put in Redis, and again we publish our data graph, and again we also add the stitching.GraphQL to our domain service, and we extend the product with the inventory. And in this service, it's different because the data shapes completely are different, and I don't want them. So in this instance, I drill into the inventory info and just pick a certain field. I also could aggregate. If that would be a list, I could still drill in and aggregate. So this pass syntax is very, very powerful. And also I have here a shipping estimate algorithm that I will use. And this is also just a scalar. So I'm creating here two new fields and are just using some functionality of the server, not all of it. Like I did with all the others where I always integrated the full type. And that should already be available. I have the in-stock info and I can get the shipping estimate. The last thing we really need to put in here is, there's one error I just saw. I just messed this up. The snippet tool always swallows my dollar signs here. Okay, so that is in. Let's just verify that it works. No, it doesn't. Top products, let's take these guys out. That works. In stock. that. Does it work now? Yeah, now it works. And this shipping estimate. Okay, it's a shipping estimate that makes the problem. Let's have a look. What it actually is, dollar price, dollar field. It actually looks good. But okay. Shipping estimate. Okay, I don't know what I messed up with this field. Doesn't matter, it usually works. Okay, let's go to the review service and integrate here the rest of it. And that essentially is extending the product types with the reviews. So now my product will essentially have a list of reviews to that product. And this lets me really now also drill into my graph, my data graph from the product side. So I can drill now in here, reviews. I can go in the author of that review, get the name here, and also from the reviews, get the body. Try and run that, look at the result a bit, and I can see here that I have a table that is in stock, and I'm drilling in and pulling up the review body here. Ada Lovelace loved it, so it works. So this is pretty easy to build up your graph. And this essentially lets you really drive all this from the domain services. You don't have to wait for one another to deploy a new gateway, because you can do everything from the downstream services. So there is another thing here, because sometimes you want to mix approaches. While we use now a federated stitching approach here, sometimes you really want to add some logic to the gateway. Maybe you have a very static logic that does some things, integrate some data, modify some data. Since this gateway essentially is a simple GraphQL server, you can also really put here everything in that you would in a standard GraphQL server. So I could also just create here maybe a code first type extension, like let's call it queries. And this queries type extends an object type. In this case, we are extending queries, and even brings in its own type. Let's call it maybe the address. And we just give it a street. And maybe we are letting people ask for the address of the company or something like this. So we just say address, get address. And then we return our address object here, which says some street. So this is now in our gateway. And we can now just say add type extension. And instead of using the GraphQL syntax, we are now using these nice C# types that already bring their resolvers with them. And this is not queries, this is query, sorry. And already our system should have be reloaded. We can see we have here now a field address, and I could ask for that and already have this object in here. and can see that that really also integrates in our data graph. But the really cool thing is that we also could interconnect these things. Like we could interconnect that with the data that comes from the downstream services that I don't even know that the downstream service is pushing up to us. So we could introduce another extension that is our user. So we call it even user. And we just say this user essentially has an address. I know it's the same address over and over again. We could also just inject here the user ID and then transform this address and really look it up. But demo purposes, let's just keep that simple. So we are extending the user, and that's a central approach, I would say, where we just say add type extension, then put in the user. And again, this is a type extension. This is actually not the user. That is just the user in our context, but it extends the user of the overall graph. So our graph should already have reloaded. And we should be able now to sit here in our user and ask for the user's address. And that's just in there. Address does not exist on the type user. Okay. That I messed up, was totally improvised. But essentially this would work under normal conditions. I don't know why it delegated it yet. Okay. But essentially you can drive the graph from two directions. You can either use the central approach to advance your graph, or you can change it from the domain service. And this means that now I'm really able to change things in my accounts graph, like go in here and maybe also introduce from the bottom up changes to my system. For instance, I could remove the username and we say, okay, name is enough. We don't need that username. And then just get rid of this here. And have a look at my overall graph again, where at the moment we still can see the username. And when we refresh, we can see it's gone. So now the team that is owning the account service is totally enabled to just push their changes, to push their graph, and don't always be blocked by the other teams. There's one more aspect I want to highlight here. And that's why we also introduced that whole thing with Redis, that we allow the configurations to be stored. There is a federated approach where you essentially pull in the changes from your downstream service. So the gateway would occasionally pull and refresh the schemas that are now in refresh downstream services. But this always introduces the problem that the gateway would need to stitch every now and then. With the Redis approach, we essentially push the schema configurations to the Redis and then do in the background the schema stitching and store the stitched schema on the Redis. Meaning that if any service in our federation would go down, has an error, the overall graph wouldn't be affected. Let me demonstrate that. Let's go back to our project here and introduce a change that essentially breaks our graph for a minute. So we go to our user. And this time we are reintroducing the username. And this will now yield in a compile error. So we can see this doesn't really work anymore. And that means our TIE orchestrator cannot get this machine up anymore. And that's actually exactly what I want here. Since now, if I execute against that, I can see there are errors against the data graph. But actually, there are only errors to the data portion that works with the user. So if I, for instance, just get the products, I don't have any problem. And I also have no problem if I fetch the author here, want the name. I get an error. That's true. But GraphQL is actually very good at working with partial data. So GraphQL doesn't just fail. GraphQL will still give you the data that is valid and just return null for the author, because the author in this instance was nullable. That means I still can use all the products data, and my whole data graph doesn't go down just because some developer made a change that really affected my overall graph. That can also be combined with things like Kubernetes, where you first try to push the new configuration to Redis, and then if we cannot stitch that, this will lead to a health check problem. So you can implement a health check there, and then Docker will or Kubernetes will just roll back your container, and your old graph will be fully intact. But even if there are things like the database is down from one of the microservice services or domain services, you will still be able to consume most of the data that you have in your data graph. And I think that is, from a resilience perspective, really a nice thing. So let's put back the data graph in order. Save that. We are redeploying the whole thing, and now we have an intact graph again. Okay, back to my slides. We have a couple of minutes for questions in a minute. So we built a distributed graph with GraphQL. We saw that it's actually not so difficult and really enables you to iterate faster. With federated graphs in GraphQL, you are more flexible. It adds complexity, especially you have to think about things like rollbacking your container and stuff like that. But it adds more flexibility when you are spreading out your team, when your data graph grows, when more teams are involved. I would definitely always tell people to first start without schema stitching or without federated graphs. Just build a single monolith at the beginning because it's super easy. And then spread out the work. And that is actually really simple to do. You can even first start doing local schema stitching, where you start to create multiple schemas within one service and spread them out slowly. And then when you're ready, you move them into a separate service. So there's actually no reason to immediately start with schema stitching. But it is something that you should consider when your data graph grows and grows and you are suddenly having problems to deploy the whole thing because you always have to deploy everything. There are multiple approaches to these kinds of distributed graphs, as we saw, schema stitching, where we can do a central approach. And there's also the approach where you push data in a federated setup. Yeah, you can deploy faster and you can deploy more easily with this setup, since you essentially can push micro changes to your domain services and swap out just small units of your graph. It also divides the graph in logical concerns, like the account, inventory checks, and stuff like that. If you want to try it out, get to our GitHub repository or head over to our website at chilukim.com. And if you have questions, I would be open to answer questions now.
I've got a question. It's not related to the talk exactly, but I saw you using Project Thai. And
yes.
One of the new things in .NET 5 is that when you're using .NET Watch and the application changes, your browser is refreshed as well. Does this work with Project Thai?
Not really. No, that is not Thai. That is
I've never used it, so I was wondering.
Yeah, it is super fast. It just switches out the parts that you need to read out. I really like it for demos and also for working locally. It's nothing. I mean, when you publish your stuff, you use things like Kubernetes, but this is always a pain to set up. In the Thai configuration, actually, you can put everything together. Like I have here the Redis container that I used, and this is just being pulled down from Docker Hub. And then I have my projects, and everything is set up nicely. So it's really a nice thing. And one cool thing, I don't know if you have seen that. You can go here on the Thai dashboard. And then you have essentially an overview over your services that are running.
Oh, cool.
You can see that here's the container and stuff. So there's always a management instance, and you even can intercept the calls between the containers and stuff. So that is an option that you have to configure. But then Thai will issue like site containers to intercept the communication between all this stuff, and that is really great to debug. So I love this thing.
Yeah, that's awesome stuff. I have to try it. Thanks.
Yeah, you're welcome. Okay, if you also have questions afterwards, you just can ping me a message.
Is the project up in like GitHub, or is it on your website?
You mean the Hot Chocolate project is on
what
GitHub?
you've just been using, yes.
You mean Thai, or you mean the
No, the main talk.
Okay. Just making sure. Here's Hot Chocolate. The whole code is here. It's open source. It's under the MIT license. So fork it, have fun with it, use it, or give us a star if you liked it. We always appreciate that.
Mm-hmm.
There are more tools to that. We not only have schema stitching, GraphQL server, we also have a GraphQL client for .NET that is fully typed. And we are one of the fastest GraphQL servers that are out there. We just released version 11.
Cool. Okay.
If somebody's interested in GraphQL, we are at the moment, it always changes. Mm-hmm. Because as soon as you put out benchmarks, somebody else will try to beat you.
Always the way. Yeah. Thanks for the talk. It's really been helpful.
You're welcome. Good. I will be available on the Slack channel, so you can also shoot me a message, and I will be sure to answer.
Sorry, one quick question. The repo you showed, during the presentation, is it available on GitHub? Well, I presume it is, but can you?
You mean the example?
The example, yeah.
Oh, yeah. It is. I have. There are examples, but this with Thai, I haven't pushed to our example repository. So usually the examples are here, but I always put my public speaking demos up, and essentially you can go to my repo, Michael Staib public speaking, and then you can look NDC London.
Okay.
And then the whole demo is here. There is actually a better way. We have this workshop repository, which has a guided walkthrough to all GraphQL. And if you here go on version 2, you also have a scripted version of all the schema stitching variants, like the schema federation with Hot Chocolate. And there is even the scripted version that you can try out yourself to build that up.
All right, that's great. Thank you.
I can post that to the Slack channel, and then you can find the link. That also has all the nice Thai magic in it.